Hello class, this is chapter 12, assignment question number 6. In this question, we deal with um, a hypothesis testing problem. And if we read the description, a supermarket chain wants to know if their buy one get one free strategy works or not. Okay? So they took measurement on in 10 stores about the traffic, customer traffic with the program and without the program. Okay, so we got this data. Okay, and the first question is asking if the data are paired or not. So in this question, we know the measurements are taken for each store. So we have to compare with program and with program in the same store. We cannot compare the without program data in store 1 with the with program data in store 2. We cannot do this comparison. All the comparison have to be in the for the same store. So it's a paired data. Okay. So yes, the data are paired because the measurements of the customers were taken at each store twice. So that's the reason. Okay. And the next, we want to calculate the mean difference. Okay, the mean of the pairwise difference. But let's do a hypothesis testing. And then we should be able to find the mean difference. So let's open the StatCrunch. Okay, so let's not do that. Let's just open the data table in the StatCrunch. Okay, let's open the data table in the StatCrunch. Okay, and we got the 2 columns of data. So let's do this stat. T-stat we know is talking about the mean comparing 2 means, and we use this paired. Okay, so let's click this paired. Then we get the data for the with program and without program. Okay, let's click this save the differences. So then we will know why we choose this one later. Okay, then the hypothesis setup. So we assume that there's no difference with program and without program. So if the mu d is equal to 0, and the alternative is that with program, the program will increase the customer traffic. So the difference is greater than 0. Okay, so that means with program, the customer traffic increases, so it's greater than. Okay, then let's click compute. Okay, and after we click compute, we have one more column, so difference. So this column shows the difference between the first 2 columns. Okay, so we're going to use this column later. Okay, but for this one, for the part B, we want to know the mean difference. Okay, the mean difference. How can we find the mean difference? Okay, the difference is 0.5. Okay, so that's the mean difference. Let's copy and paste. Okay. Okay. Then part C, we want to calculate the standard deviation of the differences. So that's when we want to use the third column. We want to find the standard deviation of this column. So let's click stat, summary stats columns. Okay, so let's select the differences column, and we only need the standard deviation. Okay, let's select the standard deviation, then let's click compute. Then we will have this standard deviation. So let's copy and paste. 2 decimal places, let's be careful. Okay. Then we need the standard error. So the standard error, we have that standard error here. So let's just copy paste. Okay, and again, 2 decimal places. So that's going to be 2. And T statistic, we have that. T statistic. And be careful now, we are saving 3 decimal places. Okay. And degree of freedom, let's go back. The degree of freedom, we have the information here. So the DF, the 9. So let's just put 9 here. Okay, so it's the alternative one or two-sided. So when we set up the hypothesis, we set in the alternative is greater than 0, so that's going to be one-sided. Okay, so this one-sided because supermarket chain wants to know if the traffic increased. Okay, and what is p-value? So let's copy the p-value here, paste 4 decimal places, so we are good. And at alpha of 0.05, so significance level is 0.05, so what's the conclusion? So the p-value is greater than the alpha level. So let's do not fail to reject, because when the p-value is greater than alpha level, we do not reject because there is not enough evidence or insufficient evidence to say it's not the null hypothesis is true. We don't have the sufficient evidence to say the null hypothesis is wrong. Okay. Okay, so that's question number 6.